Subtopic 6.2. In this subtopic, you are going to look at remainder and factor theorems, roots and zeros. What is the remainder if polynomial px is divided by x minus 2? We can get the remainder by using the long division method. We can still get the remainder without going through the long division. This is called the remainder theorem. We substitute x equals to 2 in the above polynomial and we obtain so this is called the remainder theorem. The remainder theorem. When a polynomial px is divided by a linear factor x minus a, then the remainder is pa. Let px be a polynomial of degree n greater than or equals to 2, such as quadratic, cubic. Then px is equal to qx x minus a plus rx, where x minus a is the divisor. When x equals to a, pa is equals to qa a minus a plus ra. Since a minus a equals to 0, then the remainder is pa. If any polynomial px is divided by x plus a, then the remainder will be p negative a. If any polynomial is divided by ax minus b, then the remainder will be pb over a. Find the remainder when px is divided by x plus 3. If you have a divisor of x plus a, then the remainder will be p negative a. So p negative 3 is equals to 19. Without using the long division method, we get our remainder by using the remainder theorem. If we have a divisor of ax minus b, then our remainder will be pb over a. So we substitute x equals to 1 over 3 and we get negative 311 over 81. So without doing the long division, we can get the remainder by using the remainder theorem. Example 2. When a polynomial is divided by x plus 2, the remainder is 16. We have to determine the value of k. By using the remainder theorem, r is equal to px. So from this statement, we know that we have p negative 2 is equal to 16. We let px to be x power 4 plus kx cubed plus 5x squared minus 6x minus 8. And we know that p negative 2 is equal to 16. We substitute x equals to negative 2 and we have k equals to 3. The polynomial left a remainder of negative 8 when it is divided by negative 1 and a remainder of 11 over 2 when it is divided by 2x plus 1. Determine the values of a and b. So to find a and b, we have to create two equations because two unknowns, two equations. So from the first statement, we have p1 is equal to negative 8. And here we have p negative 1 over 2 is equal to 11 over 2. So we let px to be the polynomial given. So by using the first information, we get our first equation. By using the second information, we get our second equation. So two equations, two unknowns. Solve the two equations simultaneously to get b and a. Example 4. Given a polynomial when px is divided by x plus 2, the remainder is twice of the remainder when px is divided by x minus 1. So, when px is divided by x plus 2, we have here p negative 2. The remainder is twice the remainder when px is divided by x minus 1. So we have here p1. So we have here px is equal to 2. And we have p negative 2 is equal to 2p1. Substitute the corresponding values of x. We have a equals to negative 3 over 2. When a polynomial px is divided by a quadratic expression, then the remainder is linear. If our divisor is a linear expression, then our remainder will be a constant. But if our divisor is a quadratic expression, then our remainder will be a linear expression. Example 5. Determine the remainder when px is divided by x squared minus 1. So x squared minus 1 is our divisor. We can factorize x squared minus 1 to be x minus 1 and x plus 1. So now we have px is equal to qx dx plus rx. As we have a quadratic divisor, then our remainder will be in a linear form. So we have when we substitute dx, we will have our remainder is ax plus b. Therefore, we have to create two equations to find the values for the two unknowns. By looking at the divisor, we can choose x to be 1 and x to be negative 1. As px is equals to rx, therefore, when x is equal to 1, p1 is equals to r1. So our first equation will be a plus b is equal to 15. When x equals to negative 1, p negative 1 is equals to r negative 1. And our second equation will be negative a plus b is equals to 3. By solving the two equations simultaneously, we get b equals to 9 and a is equals to 6. Try to do example 6. The value for p will be negative 3 and the value for q is negative 2. Factor theorem. If the remainder obtained from dividing the polynomial px by x minus a is 0, then the linear term is called a factor for the polynomial. It means that if we have a 0 remainder, then x minus a is a factor of px. If x minus a is a factor of px, then pa is equal to 0. If ax plus b is a factor of px, then p negative b over a is equal to 0. Example 7. Determine whether the following linear functions are factors of the given polynomials. So determine whether x minus 3 is a factor or not. We can substitute x equals to 3 in the polynomial. If we get p3 equal to 0, then x minus 3 is a factor. Since p3 equal to 0, then x minus 3 is a factor of px. If p3 is not equal to 0, then x minus 3 is not a factor of px. Example 8. If 2x plus 1 is a factor of polynomial px, find the values of p. From this statement, we have p negative 1 over 2 is equal to 0. By substitute x equal to negative 1 over 2, we get p to be 21. Example 9. The polynomial is exactly divisible by x minus 4. Find the constant k. Exactly divisible by x minus 4 means that x minus 4 is a factor of this polynomial. When we say that x minus 4 is a factor, it means that this polynomial will have no remainder. Let px to be x cubed minus 13x plus k. When x minus 4 is a factor, we have p4 is equal to 0. We substitute x equals to 4 and we get k is equals to negative 12. Example 10. The polynomial has a factor x minus 1 and gives a remainder of 50 when divided by x minus 3. Determine the values for a and b. When the question states that the polynomial has a factor of x minus 1, it means that p1 is equal to 0. And the polynomial gives a remainder of 50 when divided by x minus 3. From this statement, we know that p3 is equal to 50. To find two unknowns a and b, we have to create two equations. We let px to be 2x cubed plus ax squared plus bx plus 8. By using the first information, p1 equals to 0, we get a plus b equals to negative 10. By using the second information, we get 3a plus b equals to negative 4. By solving equation 1 and 2 simultaneously, we get a equals to 3 and b equals to negative 13. Example 11. Given that x plus 2 is a factor of 2x cubed plus x squared plus kx minus 4. So first we have to find the constant k. Hence, we have to factorize the expression completely. Factorize the expression completely means that the polynomial will have no remainder. X plus 2 is a factor means that p negative 2 is equal to 0. So we let px to be 2x cubed plus x squared plus kx minus 4. By substitute x equals to negative 2, we get k is equals to negative 8. Given that x plus 2 is a factor, so px will be divided by x plus 2. You have to make sure when you perform the long division method, you will end up with no remainder. Recall that when we have a polynomial divided by a divisor, we will have a quotient and a remainder. So, if you have px divided by dx, it means that we will have qx plus with rx over dx. But when our remainder is 0, we end up with qx. So to factorize px completely, we will have px is equal to qx times dx. Therefore, 2x cubed plus x squared minus 8x minus 4 is equals to qx dx. 2x squared minus 3x minus 2 times with x plus 2. We have to factorize the polynomial completely, so make sure you factorize the quadratic as well. So you have 2x plus 1, x minus 2, and x plus 2.